Gravitational waves ripples in spacetime. Gravitational waves are among the most exciting discoveries in modern physics. These ripples in spacetime are created by some of the most violent cosmic events, like the collision or merger of massive objects such as black holes or neutron stars. Traveling at the speed of light, these waves carry information about their origins, offering a revolutionary way to study the universe. The concept of gravitational waves originates from Einstein's theory of general relativity, which describes gravity as the warping of spacetime by massive objects. For decades, they remained theoretical, but in 2015, the Laser Interferometer Gravitational Wave Observatory, or LIGO, made the first direct detection. This breakthrough came from a collision of two black holes over 1 billion light-years away, confirming a key prediction of Einstein's work and opening a new realm of exploration. Gravitational waves reveal events invisible to traditional telescopes like black hole collisions that emit no light. These waves carry information about the mass, spin, and distance of the objects involved, providing an invaluable data set for scientists. Instruments like LIGO and its European counterpart Virgo have since made regular detections, uncovering everything from neutron star mergers to potential new physics. More than just ripples in spacetime, gravitational waves are a new way to understand the universe. Each detection is like hearing a whisper from the cosmos, revealing its most dramatic moments. As technology advances, gravitational wave astronomy will help answer profound questions about space, time, and the origins of the universe itself.